Happy Friday! So today we will continue on session 3.3 and then we will start 3.4. This week we don't have homework or quiz. Next Friday we have homework 7 and quiz 4. But do you remember last class I give you the useful formula sheet for exam 1 and 2? Please fill those out over the weekend. And then on Monday, I will ask you to show me your work. I will go check on you. Is that okay, everybody? Mm-hmm. All right. So last time we talked about division of polynomials, right? So we learned two methods. The first one is long division. Long division works for all types of the polynomial divisor. So your divisor, it could be any degree, okay? So long division works in general. And then we also talk about a shorter way, which is the synthetic division. But synthetic division is so restrictive because it only works for linear divisor. Okay, linear means the power of x must be 1. And also, the coefficient of x must be 1. Okay, everybody? So restrictive. C could be positive number, it could be negative number. So x minus c, it could be like x minus 2 or x plus 5. Okay? And let's review. So synthetic division. What do? You look at the divisor, x minus 2. Then the root is 2. Your root is always opposite sign of this constant term. Is that okay, everybody? Mm-hmm. And you put the root right here. And then on the first row, you write down the coefficient of the x powers. If you see an x power is missing, you put a 0. Is that clear, everybody? The spot is really important. For example, if you don't have an x squared, then you imagine it's like 0x squared. Then you put 0 right here. Okay? So, and then, yes, that is the first row. And then the process is you move the first number down, and then you multiply with the roots, and then write it in the next column. Okay? And then you add those two numbers in that column, multiply by the roots, and put it in the next column. So you repeat this process until you get to the end. And then the last number, is the remainder. And then the previous numbers are the quotient. But when you read a quotient, you look at the last number. This is the constant term. And then you increase the power of x. So 5 plus 3x plus x squared plus x cubed. Okay, everybody? Yes? All right. So let's look at this problem. Okay, divide using synthetic division. All right, so we have x plus 2 is the divisor. What's the root? What? What's the root? Negative 2. Yes, negative. Put the sign of it. Okay, put the sign of that constant term. So negative 2. So you put negative 2 right here. And then the numerator, see? 3x cubed, and then negative 2x squared. What's the next number? Yes, it's 0. Because we don't have x. The next number should be the x, but we don't have the x. So it's like 0 times x. Okay, everybody? And then the next number, 35. Right, everybody? Yes, we put a 0 here because we don't have an x. Right, so that's why we put a 0 there. Now let's start the process. what do we do? What? Move the 3 down. Y is shifted, okay. And then 3 times negative 2 is negative 6, right? Put it in the next column. Add them, you get negative 8. Negative 8 times negative 2 is 16. 0 plus 16. 16. 16 times negative 2. 16 times negative 2 is negative 32. Right, everybody? And then when you add them, you get what? 3. Oh, you see? So the remainder is 3. And the quotient is what? You start with the last number, right? The constant term is 16. And then what? Negative 8x. And then 3x squared. Yes. So therefore, our fraction equals to the quotient and then plus the remainder 3 over the divisor x plus 2. Everybody? Synthetic division. You start with the divisor and change the sign of the constant term to get the roots. Right? You put the roots here and look at the coefficients of the numerator. Put it down. Okay? And follow the order from the highest power to the constant term. If you miss an x power, put a 0 there. Okay, everybody? And then you move the first number down, multiply, put it in the next column, add them. And multiply by the roots, put it in the next column, add them. So repeat this process until you get to the end, right? Okay, any questions about synthetic division? Okay, so for if you're coming late, please make sure you watch the lecture video and take notes. If you have questions, let me know. Okay.
We don't have to use synthetic division.
You don't have to.
Would it be easier in this circumstance?
Yes. Right. But it only works for linear divisor with the coefficient 1. So restrictive. Okay. Let's keep going. All right. Next one, the remainder theorem and the factor theorem. Remainder theorem. If the polynomial p of x is divided by x minus c, then the remainder is the value p of c. Okay. Why is that? So so here we want to use p of x divided by x minus c, right? And let's say we will get a quotient plus the remainder. Okay, let's say r is the remainder. Okay, look at this. So this is what we're doing, right? So we do the division. We get the quotient plus remainder over the divisor. Yes. Now let's multiply both sides by x minus c. Then you get p of x equals my quotient times x minus c plus the remainder. Right, everybody? This is what happens if we multiply both sides by negative x minus c. Yes, everybody? So here x minus c cancel. Quotient times x minus c. And then here, you multiply by x minus c. You get the r. Now, if we plug in c, when you plug in c, you see you get quotient times. Do you see c minus c here? When you plug in x and c, you get c minus c, which is 0. Right, everybody? Plus the remainder. 0 multiplied by anything is 0. Therefore, P of C is the remainder. So this is the remainder theorem. Okay? If the polynomial is divided by x minus c, then the remainder is the value P of c. Okay, everybody? Mm-hmm. Okay, so instead of finding P of c by directly plugging in x equal to c, we instead to use embedded division since the remainder will be P of c by the remainder theorem. Okay, so example, let P of x be this polynomial. Use synthetic division and the remainder theorem to find P of -2. Okay? So the direct way would be plugging x is -2 and then you need your calculator, right? Because it's a big polynomial, you plug in 3, -2 to the 5th, plus 5, -2 to the 4th, etc. Okay, this is how you plug it. But now the problem says we want to use synthetic division and the remainder theorem. Okay, so in this case, the root is -2. Okay, so c is the root. X minus c is the divisor. Okay, everybody? So if you want to use synthetic division, the root is -2.
How do we decide that P P negative, how the root is -2?
Oh, because the problem says find P of -2. The problem tell you P of -2, then -2 is the C. Yes, -2 is the C. Then the divisor is x minus c. So in this case, the divisor is x plus 2. Right. Yeah. Okay. So we got 3, right? X to the 5th and 5, x to the 4th minus 4, x cubed. And then what? 0, x squared. And then 7x and 3, right? We put down the coefficients of the x powers from the highest order to the constant term. So far, so good, everybody? Mm-hmm. Okay, now let's start the process. How about you guys take turns to answer my questions? Quinta, what do we do? Okay, so please make sure you review your lecture videos, okay? Mm-hmm. We move the 3 down, right? And then 3 times -2 is, yeah, so we put it here. Diana, 5 plus -6 is -1. -1 times -2 is 2. Haley, -4 plus 2? -2. -2 times -2. Yes. 4. Nikema, 0 plus 4. 4 times -2. Zach, 7 minus 8. -1 times -2? Yes. 3 minus 2. Yeah. You see, the remainder is 1. So, negative. Oh, yes. Thank you. Right. Thank you. Yes. And so O is 5. Right. Thank you. The remainder is 5. See, sometimes I make mistake too. We're all human beings. It's okay to make mistakes. So check our work carefully. Okay, good. So by the remainder theorem. So by the P of -2 is the remainder, which is 5. So far, so good, everybody? Okay, so this is the example. Any questions about this example? See, we do, the calculation in this case is simple. Then you plug in all the powers. Think about it, if you plug in 5, 2 to the 5th, 32, and it's -32, and then you multiply by 3, so it's positive. Yeah. In this case, this is easier. Okay, so practice I will let you do at home. And yeah. And then factor theorem. A number C is a 0 of P of X. So 0. Remember 0 is the same as the roots. So that means P of X is 0. Okay, P of C is 0 because C is a 0. Okay, we plug in P of X, we get 0. If and only if X minus C is a factor of P of X. Okay, so which means P of X equals to X minus C times something. Okay, even only if. Think about it. P of X equals X minus C times something. So when you plug in X as C, do you see C minus C is 0? And 0 times whatever is just 0. Right? Yeah. Okay. So therefore each 0 corresponds to a factor. And each factor corresponds to a 0. And if you can remember like what we did before, if you have like x minus 2 to the 4, 3x plus 7, and 10x minus 1, something like that. Okay? And this is a factor. And then how do you find the roots? You set each factor equal to 0 result. Right? Anybody? Okay. So example, use the factor theorem to show x minus 2 is a factor of P of X. Okay, so use the factor theorem. X minus 2 is a factor if and only if, by the way, this symbol is if and only if. If and only if, so x minus 2 is a factor. What is the root? Is it minus 2 or 2? 2. Very good. Change the sign. If and only if 2 is a root of P of X, that means you want to plug in P of 2 and you want to get 0. Let's see. We plug in P of 2. Do you see 2 cubed? Yeah, plug in X is 2. We get 2 cubed plus 2 times x squared. X is 2, so 2 squared minus 3 times x. X is 2, and then minus 10. Okay, Justin, what's 2 cubed? What? 8. Oh, and then 2 times 2 squared is also like 2 cubed, right? 8. 3 times 2, Ethan.
I don't know.
You know. Okay. What's the answer? 8 plus 8 minus 6 minus 10? 0. Right? 8 plus 8 is 16. 6 plus 10 is also 16. 16 minus 16 is 0. Yes. So 2 is actually a root of the P of X. Therefore, by the factor theorem, x minus 2 is a factor. Okay, so we can say by the factor theorem. Can I use THM for theorem? Yes, thank you. So then x minus 2 is a factor of, yeah, it needs equal to 0. If it's not 0, then it's not a factor. Right. So far, so good, everybody? Okay. Now let's look at some crazy polynomials. Is x minus 1 a factor of this? Think about it. You don't want to use synthetic division or long division, right? Come on. 345. You want to do that? No way, right? It has 345 coefficients. You don't want to do that. So x minus 1 is a factor if and only if what? What is a root? Yeah, 1. 1 is a root. So we plug in 1 into the function. Yeah, everybody? We plug in 1 into the function. So 1 to the 345. 3 times 1 to the 172. 2 times 1 to the 11 plus 7 times 1 squared minus 9. 1 to the whatever power is 1. Ooh, you see, this is 1. 3 times 1 is 3, minus 2, plus 7, minus 9. What's that? It's 0. Right, everybody? Oh, awesome. 1 is a 0. Then by the factor theorem, x minus 1 is a factor of the p of x. See, this is much easier than synthetic division. So if you want to know whether a nonlinear factor is a vector of the polynomial, you plug in the roots to see if it's 0. Okay? All right. Okay, now you do this problem. Yeah. Oh, it's the previous worksheet. You got something like that? Oh, so something that said so
Oh, yeah.
yeah, so it's not 0. Then you say okay, good. So let's check our work. This is 3.3. Bless you. Okay, so right. Okay. Yes. So you plug in 1 and you get negative 1, right, everybody? So it's non-zero. Therefore, 1 is not a 0. By the factor theorem, x minus 1 is not a factor. Okay, everybody? Yes.
When you start out with like 1 to the power 51,
Yes.
write the 1 under that. Then when you have 1 to the power 22, it's like it just disappears. Do you not just write it down?
Oh. So because like 1 to the whatever power is 1. So this is 1.
Yeah.
And then this is like 2 times 1, so it's 2.
Oh, you multiply.
Yeah, I multiply. because then you don't need to write out another line to circumscribe. Right? Yeah, feel free to write more detail. Yes, feel free. Okay, good. Yeah, if you have questions, ask me. Very good. Keep up the work. Okay, so next one is 3.4, zeros of polynomials. And 3.4 is the last session that covered in exam 2. So after this session, you are ready to do your practice exam 2. And promise me, this time, you're going to do your practice exam 3 times. Okay, promise? 3 times, okay? And make sure you, yeah, sure, and use pencil to finish your work first. And then when you look at the solution, write down the correction. Peter, write down the correction. Yes. And then try the answer again and redo it. Make sure you can memorize all this stuff. I hope you get a much better grade in exam 2. All right, so yes, session 3.4, zeros of polynomials. So we have the rational zeros theorem. Okay, so it says if a polynomial has integer coefficients, then every rational zero of p of x of the form p over q, where p is the factor of a0 is the constant term. Okay. So this is the constant term. And then q is a zero of the leading coefficients. So you look at the constant term and what are the integer factors of it. And you look at the leading coefficients, what are the integer factors of it. Then your possible roots will be of the form of the integer factors of the constant term over the integer factors of the leading coefficients. Okay? So all your rational zeros must be in this form. Okay, so for a polynomial, your zero could be real numbers, right? It could be complex numbers, right? And if it's real numbers, it could be rational numbers, or it could be irrational numbers. Okay? So this theorem says that, so your possible roots, your roots could be complex numbers or irrational numbers or rational numbers. Okay? But if your roots are rational numbers, it must be of this form. Okay, everybody? So if we have a complex number or irrational, then this theorem does not apply. This theorem says if you have a rational root, it must be of the form of it's a factor of the constant term over the factors of the leading coefficients. Okay. Caution! The theorem above gives us a list of potential rational zeros of a polynomial. If a polynomial has any rational zero, they must be on the list. But not all the number on the list will be the zero of the polynomial. Usually, degree n polynomial will have at most n roots. Okay? So, degree m polynomial has at most n roots. Okay, so not all the numbers on the list are the rational roots of the polynomial. Okay, so let's do examples. Yes, examples help us to understand. So example 1. Use the rational zero theorem to list all possible rational zeros of the p of x. Okay, the first thing you look at the constant term and you write down the factors of the constant term. Okay, integer factors. So you always start with 1. And then what are the other factors of 3? 3, yes. So integer factors of 3 with 4 numbers. Plus or minus 1, plus or minus 3. Okay, everybody? So they are integer factors of the constant term. And then you look at the leading coefficient. You write down factors of the leading coefficient. You always start with plus or minus 1. What's the next factor? Oh, plus or minus 2. And then? Yeah, plus or minus 4. Right, everybody? Okay. So what are the possible roots? So possible roots are you use these number divided by those numbers. So these numbers divided by those numbers. Let's see what happens. Okay, let's do it one by one. Plus or minus 1 over plus or minus 1 is a plus or minus 1, right? Plus or minus 3 over plus or minus 1. Plus or minus 3. And then plus or minus 1 over plus or minus 2. Yes. Then plus or minus 3 over plus or minus 2. Yes. Plus or minus 1 over plus or minus 4. Plus or minus 1/4. Plus or minus 3 over plus or minus 4. We get plus or minus 3/4. Is that okay, everybody? You use these numbers divided by those numbers. And
Why don't we use like fractions for factors?
oh, that would be so complicated because there's so many, the infinite many fractions. So the theorem just says, look at the integer factors. Because fractions, a lot of infinite many fractions, right? You can put your denominator to be anything. So everybody okay how we get the possible roots? You use the factors of the constant term over the factors of the leading coefficients. Can you tell me how many numbers are there? 6, but each one is plus or minus. So 6 times 2 is 12. So here we have 12 numbers. What's the degree of the polynomial? What's the degree of the polynomial? 5. So you see, we should get at most 5 roots. And we have 12 numbers. Okay? So not all of them are the roots of the polynomial. Okay? At most 5 of them are the roots of the polynomial. But in reality, maybe your roots are complex numbers, maybe your roots are irrational numbers. So the number of rational roots may be less than 5. Okay, everybody? Mm-hmm. But the theorem says if we have a rational root, then it must be from this list. Okay? So this is how we get the rational root. Okay, now example 2. Let's completely factor this polynomial. Okay, so it's a longer process. So first, we look at factors of, what's the constant term? Peter. 6. What are the factors of 6? Plus or minus 1. And plus or minus 6. Good. Okay. And then we look at factors of, what's the leading coefficient? Dylan? 2. What are the factors of 2? Good. Okay. Possible root. plus or minus 1 is. Mm-hmm. And then plus or minus 2 over plus or minus 1? Yes. And then plus or minus 3 over plus or minus 1? Yeah. Plus or minus 6 over plus or minus 1? Yes. And then, come on! Plus or minus 1 over plus or minus 2? Yeah. And then, plus or minus 2 over plus or minus 2? Which we already have. So we don't need to write it down again. Okay, everybody? Mm-hmm. And then plus or minus 3 over plus or minus 2? Plus or minus 3 half. And then plus or minus 6 over plus or minus 2 is? Which already have. Okay, everybody? So sometimes if you get something we already have, then you don't need to write it down again. Okay, everybody? How many possible roots are there? 12. What's the degree? 3. So at most 3 of them are the roots of the polynomial. Oh, the power, the highest power. Yeah. Okay, very good. Now we want to find a root. Okay, so maybe let me label it. Okay, so first step you find the factors of constant term. Second step you find the factors of leading coefficient. The third step you write down the possible roots, and then the fourth step you want to find one root. Okay, how do you do that? You want to plug those numbers into the polynomial. So let's do it. The first number is 1. Okay, so we try x equals 1. Okay, we plug in 1. What happened? 2 plus 1 minus 13 plus 6. Is everybody okay with that? Because we plug in 1 to the whatever power is 1. So 2 times 1 is 2. And then this is 1 is 13 times 1 is 13. Is that okay? Right, everybody? So when you plug in 1 to the whatever power is 1. And then when you multiply by the coefficient, you just have that coefficient. Is that okay, everybody? Yes? Mm-hmm. Okay. 2 plus 1 is 3 minus negative 10 plus 6, negative 4, right? Ooh, negative 4, you see, is not 0. So 1 is not a root. Then you keep going. You keep going until you find one root. What's the next number we try? So negative 1, yes. So P of negative 1 is negative 2. Yes, negative 1 cubed is negative. So negative 2 plus 1. And then plus 13. Good. And then plus 6. Ooh, is this 0? No, of course. We get a lot of positive numbers, and then this negative number is too small, right? So it won't be 0. Okay, what's the next number we plug in? 2. Okay. 2 times 2 cubed is Kara. 8. Is that okay, everybody? 2 cubed is 8. Plus 2 squared. 4. Minus 13 times 2. 26 plus 6. Right? Okay. 2 times 8. 16 plus 4. 20. 20 minus 26. Then minus 6 plus 6. Ooh, is 0. Right? Yes. 2 times 8, 16, plus 4 is 20. Minus 26 is negative 6, plus 6 is 0. Good! We find a 0. Then stop here. You don't need to try all the numbers. You just need to find 1 0. Okay? So, okay, great. X equals to 2 is a root. Then we know x minus 2 is a factor of p of x by the factor theorem. Right, everybody? X equals to 2 is the root. Then x minus 2 is the factor of the polynomial. Right, everyone? Okay. So that means p of x equals x minus 2 times some other stuff. Okay, what's the degree of the polynomial? 3. This is linear, right? Degree 1. And then this factor, you expect it should be a quadratic. Okay? So here, to find this quadratic factor, you can use long division or synthetic division. But in this case, because this is a linear factor with coefficient 1, it's easier to use synthetic division. Okay, everybody? So let's do synthetic division. Okay, let me call this step 5. Use division. So division. You either long division or synthetic division. What's the root? 2. And the polynomial is 2, 1, negative 13, 6. What do we do? Bring down the 2. 2 times 2 is 4. 1 plus 4, 5. 5, 10, negative 3, negative 6. Oh, wait. Do you see the remainder is 0? Yes, that's always the case because we're saying that 2 is a root, right? This is the remainder to be 0. So what's the quotient? 2x squared. Yeah. And then 5x, right? Minus 3. Right. You get a quadratic factor. Then you either factor it or you use the quadratic formula. Okay, everybody? So you either factor it or use the quadratic formula. Let's try if we can factor it. Okay, what are the factors of 2x squared? 2x and x, right? What are the factors of negative 3? 1 and negative 3 or negative 1 and 3, right? Okay, so let's put 1 and negative 3 here and see if that works. So we multiply the outside, we get minus 6x. We multiply the inside, we get x. You add them up, you get, negative 5x. But we have positive 5x. What do? Put the sign. So instead of plus, we get minus 1 and plus 3. Then we get positive 6x and negative x. You see how we add them up together, we get 5x? Okay. So by the way, this is how I learned factoring. But if you use a different method, please use your method. Okay? Because there are so many different ways to factor. Yes. 6 and 1 inside factoring, like here. No, you won't get that because this is 3. 3, you don't get 1 and 6. 3 is you only get 1 and 3. Because these two numbers, you multiply them, it will give you the negative.
Okay, so if you multiply the 3 times the 2, it's negative 6. You factor that negative 6. So you put that to add up to that amount.
Yeah. Here?
Yeah. you get 1, you get -1, and
This is 6.
yeah.
Oh, okay. So this two number you multiply, you get the 2x squared. But then this two number you multiply, you get the constant term. So therefore, we cannot put the 6 here. If you put a 6 here, you get -6. You don't get -3. And if you put the 6 here, 2 times 6, you get 12. And then 12 minus 6, you get 11. Is that what you mean? Oh, how about you come in front and show me what you mean? Yes, come in front and show me what you mean. Are you talking about a different way of factoring? Oh, okay. Sure, you can use other way of factoring, but do you have the same answer? No. Okay, if you don't have the same answer, then maybe you make some mistake. So do you want to show me like what you are doing? Maybe I can help you to figure out what's wrong. Oh, you are doing the grouping. Yeah, you can do that. So this is not multiplying. Yeah, so what she's doing is she rewrite this as 2x squared and then plus 6x and then minus x minus 3. Is that what you're doing? And then you have the yes. So you have the like factor out the 2x and you get x plus 3 and then you factor out the -1, you get x plus 3 and then you have the common factor of that and then 2x minus 1. Yeah, you can also do that. Right. So there are like different ways of factoring. Yes. So far so good, everybody? Feel free to use the way you learned. As long as you get the final answer is the same, then yeah, that's perfect. Okay, so what are the roots? You see this root, we already know is 2. And then this root, so 2x minus 1 is 0. What's x? 2x minus 1 is 0. What's x? Quinton, what's x? How do you solve for x? You... Oh, okay. How about 1/2? Yeah, we add 1 on both sides and divide it by 2, right? And x plus 3 is 0. What's x? -3. See? This is a degree 3 polynomial, and we get 3 roots. They are all rational numbers, okay? So in other examples, you might get, if you're not able to factor it, use quadratic formula, because you might get irrational roots or complex roots. Is that okay, everybody? So maybe it's good to recall, okay, what is the quadratic formula? What? -b plus or minus square root of b squared ac over 2a. And this is useful for irrational roots or complex roots. Okay. And multiplicity. The multiplicity of all the roots is 1. Because you see this power to the 1, power to the 1, power to the 1, all multiplicity is 1. So now here, this is degree 3, okay? So we have degree 3 polynomial. Then we use rational roots theorem, okay, rational zero theorem to find 1 root. If you have degree 4 polynomial, you need to use rational zero theorem to find 2 roots. Is that clear, everybody? Yeah, so you have to keep going until you find 2 roots. Then your P of X will be those 2 linear factors, and then the remaining one, you use observation on synthetic division. Okay, so we will continue on Monday. So if you don't understand something, please come to see me. And if you miss some of the lecture, please watch the lecture videos. Okay? Cheers. I hope to see you weekly.
So are we going to see like the international?
Yes. It will be. Yes.
It would be okay.
Yes.
And
Yes.
if you do the quadratic with that, it's the same process, but just with different threads.
Exactly.
It's different.
It's the same practice. With the product, you get concept.
Okay, thank you.
Yeah.
I forgot what time I wrote down for my meeting. I think I wrote down like 4 something.
Oh, okay. I had that sheet in my office, but I'm available. Yeah, after 3:20 I'm available, and like between 1 and 2 I'm available.
Okay.
Okay. Cheers.